We discussed what is chemistry. Now, let's talk about what is the scientific method. The scientific method applies to all sciences, not just chemistry. Even if you are studying physics, biology, geology, the scientific method applies to them as well. The scientific method is a systematic approach to the discovery of new information. You may have heard of many journals that are published, and if you are intending to become nurses, there might be journals related to your professions. If you intend to become a doctor, there are journals published by the American Medical Association in which latest research is published. All the research that we conduct in our modern world is done through the scientific method. And what exactly is this scientific method? Here is a flowchart of how the scientific method can be visualized. First, there is the observation of a phenomena. Now, observation of a phenomena doesn't merely mean that you go to the movies and see a movie, and that's an observation. Observation generally means that you are observing a phenomena in a way that it creates questions of why or how. Why did this happen, or how did this happen? That's what an observation is. As an example, let's say you see a tractor that farmers use in their fields. It's brand new, it's shiny, it's made up of iron, and you live in that part of the country, and over the course of time, after 2-3 decades, as you get older, you notice that the tractor is not shiny anymore, and even though the owner had taken a lot of care of it, it is rusting and it's falling apart. And that is an observation you just made, that the metal iron rusted, it turned reddish brown. So the question that should arise in your mind is, why did that happen, or how did that happen? Both are equally valid questions in this case, and that question leads you to propose a hypothesis, and the hypothesis is a possible answer, a potential answer. It's called a potential answer because you are not sure whether it's right. It's just your mind trying to come up with a possible reason why it happened. Now we all know what happens to iron. Iron rusts, and possibly most of you know why it happens. It happens in the presence of moisture and oxygen. Oxygen is present in our atmosphere, in our air, all the time, but without moisture it will not happen. And over the course of many decades, obviously rain and humidity would do its work and iron would rust. But if you are making this observation first time in the world, how would you have come up with a potential answer, a hypothesis as it's called? Well, you may have observed that iron rusted more after rain, or you suddenly saw small places where rust began to form after rain, and that could be your hypothesis. Your potential answer could be that moisture or humidity or rain causes iron to rust. And so now that you have proposed a potential answer, the next step is to conduct experiments that actually test this hypothesis. How would you test this hypothesis that humidity or water in the atmosphere causes iron to rust? Well, you can devise an experiment where you have a piece of metal, or rather two pieces of metal. Both must be same size. In every way they should be equal. One subjected to humidity and the other kept in a dry atmosphere, and they would both be kept for the same amount of time, and then you would take them out and see after that period of time which one, if any, developed rust. What happens if you do not notice any development of rust? In that case, you would go basically when you notice that there is no rust, it's you analyzing the data and the results. And since you just noticed that the data results do not support the original hypothesis, you develop a new hypothesis that perhaps there must be more time given or there must be more moisture that the piece of iron must be subjected to. In either case, your new hypothesis that you have, you would go and modify your experiments to take that new hypothesis into account and conduct the new experiment. And then you would analyze the data and the results you obtained from the new experiment. At one point, and hopefully at one point, your hypothesis seems to be supported by the results and data. At that point, other scientists would see your work and they would try to replicate your work in their own research, and then what you have there is a theory. You would formulate a theory based on your hypothesis. You do not call it a hypothesis anymore, but you call it a theory. The word theory has been abused in our culture, where it's thought of as a potential explanation, but in reality it's a well-tested hypothesis that is now supported by results, and that point we call it theory. What happens at that point? Once you have a theory, you could conduct more additional experimentation, and at some point, if that theory is universal enough, then what you have is a law. What do I mean by universal? Well, there are few laws in science. One of them is the law of gravity. Now, if you discover that the law of gravity is applicable everywhere on the planet, on Earth, it's still theory. We do not know whether it's applicable everywhere in the universe, but it is. We know that the law of gravity is applicable to the stars, the galaxies, and basically everywhere in the universe. Similarly, there is another law called the law of conservation of mass and energy. That's the first law of thermodynamics that we understand is applicable to everything, everywhere in the universe. So many times the scientific method stops at the point of theory and does not proceed all the way to the law, because we just do not have access to the universe to verify whether it is universally true. But that does not mean that if something is not a law and it's only a theory, that means that it should be taken lightly or that it does not have enough support. For all practical purposes, a theory is true. A theory is a very well-tested formulation that is believable. Now, let me ask you this question. If I said a statement like tractor rusted over a period of 20 years, does that statement sound like a hypothesis? Does that statement sound like a theory or an experiment, or does that statement sound like an observation? If you said observation, you are right. It's merely observation. Now, if I said that the reason the tractor rusted was because of moisture or humidity in the atmosphere, does that sound like observation, hypothesis, experiment, or theory? If you said hypothesis, that's right. What if I said that the studies have shown that when humidity is present, iron rusts? Does that sound like observation, hypothesis, experiment, or theory? It sounds like a theory, because we just said that studies have shown that iron rusts. So you should be able to analyze statements and classify them as statements of observation, hypothesis, experimentation, or theory.